Hi, I'm Ryan Day, and this is Creating APIs that Data Scientists Will Love. I'm sharing my thoughts today because I believe that to succeed in AI, you must first master APIs. And I mean this on an individual level. I'm sharing this message with data scientists who are not familiar with APIs or don't have very detailed skills in this space, that if they will build their skills in this space, it'll help them to master AI. And I would say the same thing for software developers or people who are looking to use generative AI, for instance, is that begin by working and developing your API skills if you want to move into this space. I'm going to be sharing some tips today that come from my upcoming book, which is Hands-on APIs for AI and Data Science. This is a Python development book that demonstrates tips for both data scientists and software developers and API designers. And it'll be coming out in spring 2025. So if you are interested in this topic, I would look forward to you taking a look at that book. And if you are viewing this presentation, I think you'll also like my tip sheet. So I have a weekly tip sheet email newsletter where I share tips about APIs and AI and data science, and real tech heavy generally, with some practical hands-on tips. So I'd be really flattered if you would sign up for that. Thanks. So we're going to start by walking in the shoes of a data scientist. An important thing about designing APIs and developing APIs is having empathy for the users. A wise quote from Steve Martin is, "Before you criticize a man, walk a mile in his shoes." That way, when you do criticize him, you'll be a mile away and you'll have his shoes. So with that, let's walk in a mile in the shoes of a data scientist. The Anaconda State of Data Science report is a good judge about how data scientists spend their time. And so when you combine the different responses there, they roughly fall into these three categories, plus a few extras. About 38% of data scientists' time is spent doing data preparation and data cleansing. Data munging is another term sometimes we use. And about 27% is spent developing machine learning models, training them, deploying them, using them. About 29% is creating reports, visualizations, and other types of charts and plots and things around that space. And about 6% falls into the other category. So let's take a look then what tools they're using. So data scientists use a wide range of tools, both commercial and open source, but I'm going to share just specifically open source Python tools that data scientists use according to those different areas of their work. So in that data prep and data cleansing, a common tool that they use is Jupyter Notebooks. Jupyter Notebook is an IDE development environment that's interactive, a little bit different than typical VS Code or PyCharm, some of these things. So that's something that they'll use a lot of times, especially for exploratory data analysis. And Apache Airflow is a tool they might use if they're creating data pipelines, so ELT or ETL. And a couple libraries they might use for data preparation and cleansing in those environments, or using those frameworks, would be Pandas and Polars, or a couple data frame libraries. Then into the models section. In Python, PyTorch and scikit-learn are two popular libraries for creating machine learning models. Then when they go to a data scientist or machine learning engineer is going to be deploying those APIs, they are going to be oftentimes using a framework like Fast API to do that. Flask is another one in that space. Then when they're creating reports and visualizations, Seaborn is a fundamental library for creating plots and charts in Python. And then Streamlit and Gradio are two data app frameworks in Python that allow you to create interactive data apps, web apps, using pure Python, and including a lot of these other libraries in there. So let's jump in now and let's have, I'm going to share 5 tips to creating APIs that data scientists will love. I'm going to be sharing a demonstration project, which is, this is an imaginary website, sportsworldcentral.com. So in this scenario, you are a website owner of Fantasy American Football, and you want to create an API for data scientists especially, but other users, to consume your sports statistics so they can create models and charts and interactive data apps with it. So with that background, here are the tips I'm going to share and give some simple examples of those. Number 1, provide an SDK for your API, Software Development Kit. 2, add standard external identifiers to your API. 3, enforce data type definitions. 4, provide a method for bulk downloads. And 5, support querying by last changed date. Tip number 1, provide a software development kit. And one phrase that you should hear in your mind whenever you are dealing with a data scientist as your API user is just give me the data. It's important to remember that from the perspective of a data scientist, they don't think about you having an API. They're not interested in your API per se. They just want the data that you have that it's available through it. So what might it look like if you're providing an SDK? So here is an example from an API that is available for generative AI. And so this pattern is pretty typical of the generative AI APIs that are available. So they have your API documentation. They have an ability through their documentation to register and get an API key. API keys are important for generative AI because they're charging you based on the number of tokens that you're processing. So they're going to use that for tracking your usage. Then you see also on the bottom left there is a client SDK, and so these typically have an SDK available at a minimum of Python. Most of them have a Python and a TypeScript API, SDK. So this is a pretty good baseline to think of for that. And I will just mention, before I show a demonstration of how to implement that, in the API industry, a lot of times I've seen that SDKs are considered a more mature, something that more mature API programs might share, that it might not be that common to have an SDK if you don't have a very mature API program with a lot of other things already in place. But I'll mention that for data scientists as your users, I would suggest that this really is just kind of the cost of doing business for using theirs. And so I would highly recommend including that. So here's what an SDK looks like for the website that I mentioned. So that SportsWorld Central API, we're publishing a Python SDK for it. And so the example here, if you'll notice, this is not the my company's website where the SDK is published. This is actually on the pypy.org website, and so that's where libraries are published. If a SDK is available for download with pip, and so if you see the example in the top left here, it shows how to install it using pip install. That's the typical pattern for using Python libraries. If you're familiar with Node.js, this is similar to NPM. They're about installing libraries that way. And so from the user's perspective, you'll begin to see why it's so valuable to them. So this is using the Jupyter Notebook environment that I mentioned earlier. And so what it has is shows them the code necessary for them to actually use your library. And so you've already done a pip install at this point that we showed how they would have installed this SDK. Then they're going to, in their Python code, they're going to import the two of the subcomponents of the SWC Py SDK. And 2 steps are needed here. They will create a config object and create a client object using that config. And so they've got the client object. then they call client.listPlayers, and they put that into a variable. So you can see that the SDK gives the ability for them to very simply just get the data they want. What this doesn't show is, typically when you would have just installed this in the environment, there's some environment variables that are probably set up, a API key. You may be specifying an environment that has a URL that would go with it. Some of these things, but it also has thoughtful defaults, so that those are not required in every situation. And so then once they've got this in the variable, they're using the pandas library that I mentioned before. They create a data frame, pull the data that they got from the SDK, and then they have it ready to use in this data frame. Tip 2 is adding standard external identifiers. And so these are extra reference data to join other data sets. Now, a lot of times in an API, you're going to be sharing your own internal identifiers, because that's the purpose of them, is a lot of times for letting people interact with your own data that you're providing. But what an external identifier would be in this case is, in addition to that, you would intentionally add third-party data sets or third-party identifiers to your API. And what that allows the data scientist to do is to join that, combine it with external data sets so they can enrich the data they get from your API. So an example of this for the Sports World Central is the addition of the game stats and information systems identifier. So in our API, we have an internal identifier we use for players, but in the industry, the official standard identifier for NFL players are this GSIS ID. There's one assigned to every player that plays a play in the NFL. And so the tip here would be to get that GSIS ID, add it to the fantasy website, its data, so that it can be included in this API. So I'll show you what this would look like. So here's the Swagger UI documentation for the API. In this case, the API is created with Fast API, which auto-generates the OpenAPI file for this API, and then also auto-generates and includes a couple of open source documentation. So it includes the Swagger UI, which I'll show here. It also includes the Redoc documentation. So this would be the API. And for the first endpoint I'm showing here is the get player by player ID. And so you see that player ID, there's an internal identifier that we would use to share the data on our website. But the tip here is, in addition to that, to add the external identifier of the GSIS ID. You see that for this player, Jalen Hurts. It's been added here. That's from that GSIS system. So by adding that to our API, that's going to allow the user to combine your API's data with external data. So here's what that might look like. Here's a Streamlit app. That's one of those data frameworks that I mentioned, a Python data app framework. And so this contains data. I've shown here the data sources on here, both from Sports World Central API as well as an external data source called NFL Data Pi. And in this case, the teams are getting pulled from the Sports World Central, and then the total touchdowns are getting pulled from the NFL Data Pi, which is another library available. So you see here what that would look like in code. I've shown NFL Data Pi has been pip installed. That's an open source library that it pulls NFL data, allows you to enrich a lot of your fantasy data with that. And so the highlighted code here, we're using a pandas merge function, which, if you're familiar with SQL, similar to a left join. And so we've combined the information from our API that we got through the SDK with this NFL Data Pi, and we're joining them on the GSIS ID and player ID on that one. Tip 3, enforce data type definitions in your API. And so of course, this is important for any API, but a lot of times with APIs, we may not put this front and center because the users a lot of times are going to be displaying the contents in a text HTML page, and the numeric data types and things like this, the precision of them being exactly the right data types are not that important. But for a data scientist who may be performing calculations or maybe training models based upon the values, it becomes very important that the data types be valid. So the way that we're going to declare the contract to the users of this is through the OpenAPI specification. So in that documentation I shared, if you click on this link here, that gives you the OpenAPI spec. So in that one, you'd see the paths section. So there's going to be an entry for each one of the paths, each one of our API endpoints. Here I'm showing the players path. And so down in the details about what data types are returned, it will make a reference to a schema. In this case, it's going to be a collection of player schemas. And so this is where the specific data types are going to be defined. So how do you enforce those? So in the case of this Fast API that I created, those are actually defined using Pydantic, which is a Python data validation library. And so this is the code that you use to define what data is returned by the API. Then Fast API uses Pydantic to generate that OpenAPI schema and define what the data types are. So Pydantic is playing two roles here. One is that it's an advanced data validation library to ensure that the data that is going to be returned from the API, it's going to be put into Pydantic classes, and it will validate the data before it sends it out. And in addition, it's being used to define the contract itself. So here's a good way to enforce those data types. Tip 4 is to provide a method for bulk downloads. And it's very important for data scientists to have some method of getting a full bulk download of your data set. So here's 3 ways that they might be using it that would cause them to want this bulk download. One, they may be performing exploratory data analysis. So this is whenever the data scientists first look at your data set, they're going to be using a variety of Python functions on it to look at things like the statistics of central measures, and so things like the means and the modes, and they'll also be looking for the contents of the data to see how it's distributed, what type of distributions it has. Are there outliers that need to be taken into account? Are there nulls that need to be taken into account? So all of these, it's important for them to be able to see the full data set to do this. Second is that they may be using your data to train a machine learning model. And so the typical method that a data scientist uses when they're training a machine learning model is to take your data set, divide it into a training set, which they'll use to train the model if it's supervised learning, and then a test set and a holdout set. And these are used to verify and validate the results of their models. And so they may be using sampling to sample subsets of the data as they do this. However, they need to have the full data set so that they can accurately get a sample of it. So this is another reason that they would want to have your full data set. Last one I'll demonstrate is if their data scientists are using your data in a data pipeline, meaning that they're updating systems and possibly an analytics data based upon it, then a typical pattern they would use is to perform a one-time initial load with your full data set. And then I'll show in the next tip, which is they want to do an incremental load on that one. That would be based upon a last change date. So this is an example of a flow using Airflow. That's one of those Python libraries that I mentioned. And so in this case, they've defined a graph. They call them a DAG, distributed acyclical graph. And so the part that's highlighted shows that first pipeline, which is the bulk data. So they would pull the bulk data, then they would update the database based upon this one. Then I'll show the next tip, which is support querying by last change date. And so, if they're using your data as part of a data pipeline, they want to have the ability to get the deltas, meaning the records that have changed since the last time that they queried your data. And so, if they have a recurring data update, a nightly job or multiple times a day, something like this, then the best case scenario for them is that if you have a last change date or last change date time field that they can use to be able to retrieve any records that have been modified since the last time their pipeline ran. And so I will just point out this is a column that should be technical in nature, meaning it doesn't reflect a business date or transaction date or something with business meaning. This is a standalone field that strictly refers to any modifications to the data, which would also show them records that have been inserted, update, or in a perfect world would also handle logical deletes. So this is what that field might look like on the API that's included, minimum last change date. Then if they're using this in a Airflow incremental load, you'll see then they would have a task that goes to the API and queries it based upon the last change date, and then can do an update and insert based upon those records. And then this is actually the Python code that would define that flow there. And so you'll see that they are executing the API where the last change date is equal to, should be greater than or equal to the last change date of the previous one. So those are the tips. 1, provide an SDK for your API. 2, add standard external identifiers. 3, enforce data type definitions. 4, provide a method for bulk downloads. And 5, support querying by last change date. If you'd like to get some more tips like this, one more pitch there, please sign up for my email newsletter. And thanks very much for your time.